Hi, it's Kavishkar. Today we are going to discuss a topic that is going to be a little bit different from what we have done up until now, atomic units. So this is about the universe and how as humans we try to understand our surroundings. So let's get going. We are living in a very complex world. The universe itself is very complex. Stars, galaxies, black holes, and maybe even multiverse, who knows? But essentially what we know is the universe is very complex, and maybe it's a little bit difficult for a human being to comprehend the true scale of the universe or the true complexity of the universe. You cannot go ahead and simply grasp the complexity of the universe. But it is not only the universe, it is our own bodies that are extremely complex. Our body is a highly advanced machine, and studying it is also not a simple task. So, as a result, to understand these complex topics, complex concepts, we define atoms or small unit, simplified units. So simply the periodic series, it is a simplification or an abstraction that we have made by observing the universe. By saying we have made, it does not mean that we have made the whole concept. It is out there in the universe, it is out there in the environment, but we have used this concept of dividing complex ideas into simple ideas in our human knowledge system. So any complex material is made up of these elements, and as a result we can easily understand the behaviors of the materials by simply understanding the properties of individual atoms, individual elements, and how they interact with each other. And the atom itself is a simplified unit we figured out so that we can understand our world. But unit, the simple single unit itself does not fulfill our goal. We must be able to understand how these units are interacting with each other. What are the laws that glue these units together? So when it comes to the periodic table, there might be bonds, and when it comes to the atom, there might be attraction forces between the protons and electrons, and maybe quantum effects. All these things are laws that we define to understand how these atoms or simple units interact with each other. A very simple and very common example is how we define our color spectrum. We use only three numbers or three colors to build up the whole range of colors: R, G, and B, red, green, and blue. And by combining, by adding these colors in different ratios, you can define any other color. So essentially what you have done is you have simplified the color spectrum into basic, or we will say basis colors, three colors. So as a result, our understanding of the color spectrum is refined. And so it is not only about atoms, chemistry, or colors. It is everywhere. And especially when it comes to signals, we are decomposing our complex signals into simple, understandable, and digestible simple signals. Mostly these are maybe sinusoids, cosine functions, and maybe other functions, delta functions. All these things we will discuss later, but the essential idea is, the core idea here is, we are using the decomposition of complex signals into simpler signals. We call these simpler signals basis signals, and we use these signals to manipulate our complex signal systems. And here you may see we discussed about phases and how we use phases to build signals. And actually speaking, phases are the base of all the signals we discuss across signals and systems. And here you may see the square wave itself is made up of phases, and as a result we have essentially simplified the making of the square signal. And that's it. This was a very simple video, and no mathematics was involved, but still it was very interesting. And please make sure you clearly understand the concept, the philosophy of decomposing complex systems into simpler systems. And that is going to lay the groundwork of our whole discussion on Fourier series. Thank you so much.